Okay guys, welcome back to another video. Today we are going to prove theorem 2.6.2, which states that let a and b be integers such that a is not 0 and b is not 0. Then the greatest common divisor of a and b timing multiplying the least common multiple of a and b equals the absolute values of a and b. Now, what can we do with this? The first thing I'm going to do is going to let a and b be integers such that a is not 0 and b is not 0. I try to have the greatest common divisor and the least common multiple of a and b. So I gotta have to write like this. I gotta have the greatest common divisor of a and b, which is the greatest common divisor of absolute value of a and absolute values of b. Because the greatest common divisor of a and b is the greatest common divisor of minus a and b, and the one of a minus b, and the one of minus a and minus b. So I can write the greatest common divisor of a and b equals the greatest common divisor of absolute value of a and absolute value of b. And the least common multiple of a and b is going to be the least common multiple of absolute value of a and absolute values of b, because the LCM of a and b is the LCM of minus ab. It is and is also can be and it can be the LCM of a minus b, and it can be the LCM of minus a and minus b. Okay, so it is enough to prove that to prove the case where n and b are both positive integers. Okay, what next? The next thing I'm going to do is to let d to be the greatest common divisor of a and b. Okay, so that means that we have d divides a and d divides b. Okay, so that means that we gonna have integers q1 and q2 such that a equal to q1d and b equals q2d. This is by divisibility. I want to have a times b. Okay, so we're gonna have next, what we have next is a times b equals to q1d times q2d. Okay, so we're gonna have q1 q2 times d squared, and we divide both sides by d. We're gonna have a times b over d, which is q1 q2 d. So we're gonna have q1 q2 d, and this q1 q2 d is b, so we're gonna have q1 b in here. And the next one we have a times b over d, which is also which can be a q2 q1 d, and q1d is, what is q1d? Is a, so we gotta have q2 times a. Okay, great. So since we have d divides a and d divides b, that means that a over b is divisible by d. Okay, so that means that we can have integers. I will call it m. So I'm gonna let m to be a times b over d. Then what do we have? M is now A, B over D. What we have next is we get to substitute this A, B, I lost where it is, this one, okay? Then we gotta have M equal to Q1B and M equal to Q2A. That means that M is a common multiple of A and B. Okay, now since Q1 and Q2 are integers and we have M equal Q1B and M equal Q2A. Okay, so we gotta have B divides M and A divides M. Okay, from this one right here, it means that M is a common multiple of A and B. Okay, is a common multiple of A and B. This is what we have. And now we have a common multiple of A and B. I want to show that this M is the least common multiple of A and B. So we have to claim that M is the least common multiple of A and B. Okay. Then what can we do? The next thing we're going to do is to let C, which is a positive integer, such that A divides C and B divides C. Meaning, I let C to be a common multiple and try to show that C is less than or equal to, M is less than or equal to C, because I want to show that M is the least common multiple. Okay. Now, let's talk about A divides C and B divides C. So by divisibility, we gotta have integers k1 and k2 such that C equal to k1a and C equal to k2b. Okay. Then what do we have? We gotta have this. So let's go back to up here. We have these two equations, which is A Q1D and B Q2D. Okay. So since we have this one right here, and what next? Okay. So what happened to C? We gotta have C equal to A K1A, which is K1 Q1D. Okay, and it turns out to be K1 Q1D, and our C, which is K2B, which becomes K2. Now what is B? It is Q2D, which is K2 Q2D. And these are both C, right? So these terms are the same. That means that we gotta have K1 Q2D equal K2 Q2D. We divide by D both sides, we're gonna have K1 Q1 equal to K2 Q2. And then what next? The next thing we're going to have is K2 Q2 equals K1 Q1. And since Q1, I want to use K1. I want to perceive K1 as a quotient, since K1 is an integer. And K2 Q2 equals K1 Q1. That means that Q1 is a divisor of K2 times Q2. Okay. Now, let's go back to up here. We have this D, right? Which is the greatest common divisor of A and B. Okay, so since D is the greatest common divisor of A and B, and we already have these two equations, okay, which is and A equals to Q1D and B equals to Q2D. Okay, so what do we have? Let's go back to here, which is the statement that I have proved in one of my video. So if the greatest common divisor of A and B is D, and A equals to Q1D and B equals Q2D for some integers Q1 and Q2, that means that the quotient of from the greatest common divisor of A and B will has GCD of 1. Okay. So that means that we're gonna have the greatest common divisor of Q1 and Q2 being 1 right here. Now, what do we have next? Take a look at this and this right here. So since we have Q1 divides K2 Q2 and the greatest common divisor of Q1 and Q2 is 1. Okay, this is by A. Then what next? By B. What is that B? This B is here. So if you have A divides BC and the greatest common divisor of A and B is 1, then A divides C. Okay, so what we have is we're gonna have Q1 divides K2. So by divisibility, what do we have? So there exists Q3, which is an integer, such that K2 equals to Q1, Q3. Okay. Now, what do we have? Since we have K2 equals to Q1, Q3, and we have Q1 and Q3, Q1 and Q3 are above there. So I want to use this C, okay, which is K2 times B, because I want to show that M is less than or equal to C, okay? And B is with this term, which is, where is it? I lost it. This one here. Now, okay, let's use this reason. Since K2 equal to Q1, Q3, and C equal to K2B, and M is Q1B. So what do we have next? So we have this. So we're gonna have C equals K2B equals, so what is K2 is Q1 Q3 times B equals Q1B Q3. Okay, this term right here is M, so we're gonna have M times Q3. Okay, and since Q3 is an integer and C equals to Q3 times M, that means that M divides C. Okay, oh, this is what we have. When M divides C, what can we have? M is less than or equal to C, and C is a common divisor of A and B. Okay, so we can show that the least common multiple of A and B times the greatest common divisor of A and B is going to be m times d, right? And our m times d is a times b. Okay, so we're gonna have a times b, and that's it. This is what we have. So we have shown that the greatest common divisor of a and b times the least common multiple of a and b equals to a times b in the case where a and b are positive integers. And it is enough to show that this product is absolute value of a times b. That's it for this video.